आज ऑफलाइन बंद करो so this ethics, the publication ethics part, the other part of publication ethics part, this module B, this will be a what is good and what is bad. क्या करना चाहिए ethics? All are still right now, a lot of problems will be legends, but no matter. जो हो गया मेरा नहीं चलेगा 5 मिनट तो 5 मिनट दिएगा बोलो तो क्या प्रॉब्लम अभी तो बोला था कि पूछेंगे लेकिन आपको मिलेंगे सीनियर से बात करते हो मुंबई का देखिए इच्छा है तो वही करेंगे एक कॉलेज में रहता हूँ इच्छा हमारे में रहता कि कहीं तो भी लॉ मैंडेट
Hello, 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 hello.
So microphone got finally rectified, huh? अभी क्लास करना ही पड़ेगा आ गया So we come to 9th lecture, 9th and 10th lecture combined together. I will sorry there was a delay because of the microphone and also I missed the bus, huh? So anyways combined. But I came microphone का भी problem solve हो गया, so we can start. See again, as I told you कि in this class, since you are coming and listening and going, we'll see कि क्या क्या करते आ रहे हैं. Otherwise we'll forget. So here in this is module B of research methodology, research and publication ethics. So actually it's a combined program, huh? For 45 lectures. A part में 3 हुआ है research methodology में. सिर्फ हम लोगों ने theory पढ़ा है. Most of the mathematics, the techniques, the statistics are pending. Oh, that will start from Tuesday, huh? We have come towards the end, huh? Next Tuesday. So 1 week after 1 week. So here in module B, what we have learned till now is research problem, literature review, working hypothesis, research design. थोड़ा सा design बाकी आज खत्म हो जाएगा. And we are parallelly doing experimentation also. Experimental protocols क्या है, huh? Rules. What are the rules of experimental design? As we do, we are again doing a recap की research stages क्या है. So formulating the research problem, extensive literature survey, developing the hypothesis. 3 हो गया. तुम सोच रहे हो 70% क्लास हो गया, 3 में अटका हुआ है. उसके बाद मैं कुछ नहीं कर सकता. Execution of the project. मैं क्या? You have to do, huh? Analysis of data. So those everything you have to do and interpretations का थोड़ा सा करेंगे. And data collection. So there are established methods of data collection. Next class we will do data collection. Today we will complete this research design. बहुत हुआ है, enough. And collecting the data means sampling. Sampling तो कुछ हाँ वो एक slide है आज. हाँ. So डेटा कलेक्शन में मोस्टली इट इज फॉर क्वेश्चनियर्स, हाँ, सिलेबस में जैसे पिछले देखोगे. सो यू हैव टू डू दोस टाइप ऑफ, जैसे सिलेबस में क्या है, इन डेटा कलेक्शन ऑफ डेटा थ्रू क्वेश्चन एंड शेड्यूल्स. सो वी विल डू दैट जो सिलेबस में है, collection of secondary data, selection of appropriate method for collection. So interview and these methods. Then what are the guidelines for developing questionnaire, successive interview, survey versus experiment. So we have to go through that. Huh? उसका हम लोग next class will do. But your data collection will be different, huh? Because those who will be doing experiments will do collection of data based on techniques or equipments, right? Or something else. But those who will be doing theoretical research, so they will be working on the platform and they will be collecting data in a slightly different way. And the data collection for whatever is given in the syllabus is somewhat different, but we will go according to them, whatever has been proposed to us. Okay, come. And we'll just get the attendance sheet. Attendance sheet, wo de do. Sheet lena hai. Acha lane ke. Okay. So they are bringing it. So research problem we define that the first step of first stage of research, that we have to define the problem in a nice way. Abhi tak, you have already, I think, समझ गए हो, याद भी आ गया है. समझ गए तो सब लोग समझते ही है. Why that necessity of the defining the problem and a technique. So again 5 ways ये अब दिमाग में बैठ गया है और पढ़ने का जरूरत नहीं. We do not have to read before exam. We can come and write down what are techniques of defining the problem. Is that we'll propose the problem in a broad way, then squeeze it. How? We have to understand the problem. Second, we have to discuss with the experts. Third, we have to do a literature survey. Fourth, and then again we have to rephrase the problem to a working proposition. This is the technique. You write something in under each point, जो भी तुम लिख सकते हो. Then we have to do a survey of literature. So what is the purpose and benefits of survey of literature? The purpose we define that we'll understand. The purpose is that we will have a background knowledge of what we are doing, because you will be some of you might be doing research in a new area, and some of you which you are already familiar. So just those who are not familiar will have to understand the background, and also it will be required during your thesis writing, because the introduction part, as I told you, it contains the literature review, and as well as for each publication which you will be doing, you have to do a literature review. For patents, what you have to do? You have to do a patent search. Proper searching is required. Searching. If you do not, means it's a integral part of patent submission that you have to give a proper patent search. Kitna patents is, you cannot duplicate a patent. That is research problem तो तुम थोड़ा इधर उधर करके कर सकते हो, but patent is legally bound. उसमें lawyers बैठते हैं, so there is you have to face the legal team. So you have to strictly abide by the literature review. You have to ensure that your work is novel, and you have to highlight what is the novelty of your work. For a patent, patents. So this is what for a patent, and there also you need a hypothesis and what is the novelty. Purpose is that background information will be able to tell the next stage. There is hypothesis. It will help the next stage, means research design, and also the final stage, how to structure the report. Because with that reading literature, so if you read a journal article, you will be able to know how the journal article structure looks like, and you will be able to submit it. We discussed how the HBNI thesis looks like. You have to follow that template. You cannot give on your own. So you have to go through that survey. You have to do. If you are writing in journals, there are letters. 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 There are different types of journal articles. We discussed some are letters. Means short letter, chithi, letter type. So that is much shorter. So those letters are different. So you have to read a letter to understand letter कैसे होगा. You have to understand a template. कि letter का template कैसे होगा. There are communication, short communication. Short communication is around 1 page. Editorial, जो editor है वो editorial लिखता है. So they have to know how it looks like. You, by surveying the literature only, by reading, you can structure your report. सिर्फ journal article और कैसे होता है, means article, full length article, what you will be doing and writing, you have to structure it according to the journal templates. जो journal में publish कर रहा है उसका अलग अलग templates होता है. So you have to follow that. You have to read those literature and understand how the report structure look like. You have to abide by that. कुछ भी नहीं डाल सकते. Thesis में नहीं, letter ऐसा नहीं मीन्स जर्नल आर्टिकल लिख के तुम लेटर्स में नहीं डाल सकते, लेटर्स फॉर्मेट में करना पड़ेगा, कम्युनिकेशन भी सेपरेट है, रिव्यू आर्टिकल इज डिफरेंट एंड ये सब करके तुम पेटेंट नहीं पब्लिश कर सकते। हाँ, पेटेंट्स के लिए अब तो अंडरस्टैंड द स्ट्रक्चर ऑफ अ पेटेंट, हाउ इट लुक्स लाइक। हाँ, ओके, सो दैट इज टोटली डिफरेंट। पेटेंट्स के लिए क्लासेस है। हाँ, बहुत सीखोगे पेटेंट्स के बारे में। एक आध पेटेंट आएगा कि नहीं? हाँ, सबके पब्लिश तो करना ही है। होपफुल कुछ आएंगे। सो बेनिफिट्स ऑफ रिव्यू ऑफ लिटरेचर इज दैट वी बिकम फेमिलियर विद द सब्जेक्ट, वी अंडरस्टैंड द थ्योरीज बिहाइंड इट। व्हाट आर थ्योरीज? थ्योरी क्या है? हम लोग पहले पढ़ रहे ना, प्रॉब्लम एक रिसर्च डिफाइन करके थ्योरी। सो वी सी व्हाट आर थ्योरीज, जस्ट वन लाइन। इवैल्यूएट एंड असेस द प्रीवियस लिटरेचर एंड प्रिवेंट डुप्लीकेशन। सो पेटेंट, दिस इज वेरी इंपॉर्टेंट। You cannot just repeat the same novelty. Novelty statement should be different. How to conduct the literature survey? Well, primary and secondary sources. If you are doing a patent, you have to understand and read the patents like that. Choosing your sources, like relevant credibility age for patents, you have to search for beginning. हाँ, वो कुछ नहीं, पूरा देखना पड़ेगा कि कभी किसी ने ऐसा डाला है कि नहीं। It's already been done, you cannot do it. Then we had a class on how to write a literature review. And then we propose the working hypothesis. So after experiential literature survey, we'll propose the working hypothesis. What are the techniques? Again, we remember because we are repeating it every day. The discussion with your colleagues and experts, same. Huh? Examination of data and records, mean literature survey type. Review of similar studies. You have to do a review what has been done to find out the gap areas. Huh? उसी gap area में तुम hypothesis propose करोगे. Then your research will be interesting. Then exploratory personal investigation. We understood the difference between research question and research hypothesis. Okay, so research question, we understood it is a question format. It's a question, while hypothesis is a proposed answer. It's a statement format. A hypothesis has to be tested to prove it. So that testing you will do. And then we came into research design finally. And what we defined research design. What is research design? It's a structure or a blueprint or plan of your research, right? According to the hypothesis or to prove the hypothesis. And what is the need? The need, without a research design also you can proceed, but if you have a design, it will increase your efficiency, it will help in managing your time, it will minimize the bias and errors, it will be reliable, and it will give a proper direction to your research. So these are the need for the research design. And we understood the concepts, 10 concepts. We did 10 questions, question answers. आज वो repeat नहीं कर रहे, वो किया है. 10, these are important, the 10 concepts. That is, number one is variable, independent and dependent variable. Second is extraneous variable. Third is control. Fourth is confounded relationship. Then research hypothesis, experimental and non-experimental hypothesis testing research, experimental group and control group. If you so dependent variable, independent, extraneous, you understood ना? Remember ना? Control means जहाँ पे extraneous variable का effect remove कर रहे हैं. We are confounded relationship is exist. We say when extraneous variable affecting your dependent variable. Research hypothesis, we told that the testable relationship between an independent and dependent variable. Okay, and then what is experimental and control groups? Experimental groups receive the treatment. Okay, treatment is there. What is treatment? A specific intervention, a special condition applied to the experimental group. And control group is where you do not give the treatment, which is tested under usual conditions. So these are important, because we will come because yesterday when I was doing, many people were not able to grasp what are actually these. If you understand, experimental group एक रहेगा, control group एक रहेगा. Experimental group पे हम modification करेंगे, treatment डालेंगे, treatment. Okay, these are the terms. So in experimental group, we will give the treatment. In control group, we will not give the treatment. Okay. Experiment and experimental units, we understood what all this is. And then we went into the important experimental designs. Okay, last class. So we did informal experimental design. So what is informal experimental design? So those three we will repeat without the examples because we have already done, but there was some confusion. So again, we are repeating it. So before and after without control design. So you do not have a control here. Control में हम लोगों ने पढ़ा था क्या है, experiment हम लोगों ने पढ़ा था. So test area एक ही एरिया रहेगा, एक मतलब टेस्ट एरिया, एक्सपेरिमेंटल एरिया जहां पे तुम मैनिपुलेट कर रहे हो. कंट्रोल एरिया नहीं है, यू डू नॉट हैव अ कंट्रोल. ओके, so this is the very simplest form of informal design. So only one area is there where you put the treatment X, introduce it, and level of phenomena, you measure the phenomena before the treatment and after the treatment, and treatment effect to define like this. So the treatment means the manipulation or the independent variable you are manipulating. Dependent variable you are measuring under for the experiment before and after. Okay, and then you are measuring the treatment like this. The main difficulty of such a design is that with the passage of time, variable acceleration may be there in the treatment effect. Suppose these, I told you, all this research design what is there is for agricultural research. तो agriculture research में एक plot है, हाँ, एक ही प्लॉट लिया, उसके पास एक ही प्लॉट है और प्लॉट को सेपरेट नहीं किया, उस प्लॉट को ब्लॉकिंग नहीं किया, कुछ सब अलग अलग नहीं किया, उसी प्लॉट में पूरा प्लॉट में 2024 में they have planted and find out the yield. In 2025 they have planted and find out the yield and they are comparing the yield. 25 में उसने इफेक्ट इंडिपेंडेंट वेरिएबल क्या लिया, फर्टिलाइजर डाला, कोड में नहीं डाला, तो फर्टिलाइजर डालने के बाद ज्यादा बढ़ा, तो फर्टिलाइजर का इफेक्ट क्या, वो डिफरेंस इन जो इंक्रीज हुआ वो डायरेक्टली प्रोपोर्शनल कर सकते, वी कैनॉट डू इट, वी आर नॉट एबल टू डू दैट इन 2024. रेनफॉल माइट बी डिफरेंट, the soil quality might be different, the pest conditions might be different, the moisture content of the soil, moisture content of the air might be different, season might be different. So in 25 definitely an effect is there because of the fertilizer we have introduced this year, but we can not directly correlate it with the previous year. Okay, so we cannot correlate it, so because directly because of these differences. Lekin how we will remove those differences, that will come in the next design. So the treatment effect, we are doing it that we do not have a control. If you have only a experimental plot where we are doing the experiment in presence of the fertilizer, in absence of the fertilizer, we cannot correlate directly that the increase is because of the fertilizer only in this case. Slowly we have how to improve it, slowly we'll do after only, but with a control, means we'll separate the plot into two halves, or we'll do two plots, one half में 24 में भी fertilizer डालेंगे, 25 में भी 24 में ही नहीं डालेंगे, and in the next year we'll do the same thing with fertilizer, without fertilizer. Then under the same conditions, whatever increase difference in that year, previous year and this year, we can correlate, but we can only remove the effect of time, okay, not the effect of soil. So this is how introduction of the problem. Data can be collected in such a design without the introduction of problems with the passage of time. Means rainfall, season, ये सब effect nullify हो जाएगा. But if the soil quality are different, one plot, the test area is somewhere else and the control area is somewhere else, the fertility are different, we will have not a control. So for removing that, we introduce before and after with control. So before also, last year also we did it, both the places, these are also both the places. Then only we will have that both the factors with time and from the quality of the soil fertility we can get. So these were the three important experimental design informal we discussed. So remember इसके बारे में थोड़ा लिख सकते हैं, simple है, simple diagrams है, isn't it? If required, one or two you can write it. Simple diagrams है and you can just I am giving you all this. मिल रहा है अभी भी नहीं मिल रहा है, no? So I will again resend, मैं आज जाके भेज देता हूँ emails. I will send the email till class 5 I have sent you, नहीं तो मैं तो हुई कभी भी फोन करके email करके, I have last time I sent you ना, life sciences, एक भी नहीं मिला, फिजिक्स का, केमिस्ट्री ऑल्सो यू हैव गॉट ना, लाइफ साइंसेस किसी को नहीं मिला, okay, I will send you today, I have one common email ID, everybody has access, so password is there with everybody, So before going into the formal design, means the formal designs, formal experimental design we introduced last day, but I thought what I found is that there was some confusion बोलने के बाद कि replication क्या है और randomization क्या है. He knows, तुम botany से हो, फिर biotechnology, but I know everything. तो मुझे ही पता नहीं था, मैं तो अभी पढ़ रहा हूँ. But what I understood that during reading is that जो एग्रीकल्चर में जो है या बॉटनी में जो है, they are taught these things during their graduation itself. You know that. So they know that. So that is why. So first, instead of going directly into this design, first understand what is randomization and what is replication. This randomization is random. What सी आ रहा है, और replication is repetition. बार बार कर रहे हैं. Just इतना simple याद रखना है, बस और कुछ नहीं. But the terms used are different. इस methodology क्लास में research problem बोला है, but what you tell is the your research title or your objective of your research. हम terms use कर रहे हैं अलग. Objective जो है वही problem है. And then hypothesis, what are your deliverables for your research, what you will deliver at the end of the research. So that you previously I will say. So we will establish a structure property correlationship, as I told you. वो बाद में. So but here we are using the term. So here we are, instead of repeating gives you what? Reliability. एक चीज बार बार देख के तुम कंफर्म हो जाओगे, हाँ वो ही है. जैसे मेरा क्लास कर रहे हो, ये सर बेकार पढ़ाते हैं, बार बार 15 क्लास बेकार पड़ेगा तो तुम कंफर्म हो जाओगे कि नहीं, अरे क्या बाहर बोल दोगे, अरे क्या फर्क है, दिमाग. सो दैट इज रिपीटेशन. your whatever you are saying has some reliability. It's not out of the sky you are telling. एक क्लास करके you cannot judge, isn't it? तुम लोग तो जज कर लो एक बार लैब जाके. अच्छा टाइटल पढ़ के. सो फॉर रिलायबिलिटी यू हैव टू गो सेवरल टाइम्स. ऐसा मत करो, बार बार पंच जाओ लोगों को, गाइड्स को डिस्टर्ब मत करो. So for reliability you need to have repetition. So they are telling replication and again randomization. मतलब you see, I don't know whether you have faced during interview medical test हुआ. तो उसमें एक शीट दिया 50 क्वेश्चन. वो देखो एक ही क्वेश्चन बार बार रिपीट हो रहा है बीच बीच में, 5th क्वेश्चन 10th क्वेश्चन, तुमको समझ में नहीं आएगा. बट व्हाट दे आर डूइंग इज दे रैंडमली एक ही क्वेश्चन 10 बार पूछेगा और तू देखेगा कि ठीक है कि नहीं. सब ठीक ठाक सोच रहे कि नहीं, मतलब सोच एक ही जैसा है यार, का सोच बदल रहा है. सो दैट इज व्हाट दे आर डूइंग रैंडमली. कभी भी आस्क दे आर डूइंग एंड फाइंडिंग आउट ये सेम आंसर्स दे रहा है या कुछ अलग घर भर कर रहे हैं. सो ऐसे रिलायबिलिटी बढ़ेगा उसमें से ऑफ योर आंसर्स. सो दीज 2 ways यू कैन डू, रैंडम रिपीट करके या रैंडम करके. वो रिपीट भी कर रहा है लेकिन रिपीट सेम सीक्वेंस में नहीं, तुमको बार बार पूछेगा कि सेम क्वेश्चन एक के बाद एक, यू विल डेफिनेटली आंसर द सेम. बट अगर रैंडमली पूछा, एक बार 1 में, एक बार 7 में, एक बार 14 में, 50 क्वेश्चन से आंसर किया था, मैंने भी किया था, मुझे भी पता नहीं मैंने ठीक दिया है कि नहीं शब्द. So these are the 2 terms. And then principle of local control. Control means again we are not allowing extraneous variable to we neutralize the effect of extraneous variable. This is what we are doing. So 3 principles of experimental design we should understand. Then we'll go again. Otherwise we will not understand. Anyways, it's difficult to understand, but still, whatever. Jitna padhte hai. Principle of replication. The experiment should be repeated more than once. Simple as that. We are repeating it. Thus, each treatment is applied in many experimental units instead of one. By doing so, the statistical accuracy of experiments is increased. What it does, it provides protection when we conduct an experiment against the effect of extraneous factor by replication. It provides you protection against extraneous factor by repetition. Replication means repetition. बार बार repeat करके तुम कर रहे हो. So, example दिया है. For example, suppose we are to examine the effect of 2 varieties of rice. एक ऑरेंज वैरायटी है, एक ब्लू वैरायटी है. 2 varieties of rice है तुम्हारे पास. So what they are telling, for this purpose we may divide the field into 2 parts and grow one variety in one part and the other variety in the other part. So agriculture कैसा करते हैं तुम, साइंस में क्या करोगे that is different but similar, somewhat different करोगे. Now you grow, you have one field, you divided the field into 2 parts. Okay, in one part you grow orange and the other part you grow blue. What we can then compare the yield of the 2 parts and draw conclusion on that basis. तो ऑरेंज राइस का क्वालिटी और रेड ब्लू राइस का क्वालिटी हम लोग देख सकते हैं और क्वांटिटेटिव यील्ड भी देख सकते हैं. विच राइस इज गिविंग मोर यील्ड इफ यू वांट टू कंपेयर दिस. इट डिपेंड्स अपॉन योर हाइपोथेसिस. यू वांट बासमती राइस और यू वांट some cheaper variety of rice in more quantity. Whatever. Your independent variable is your decision. Dependent variable you have to find. So, but if you have to apply the principle of replication, then we have to repeat it. So an agriculturist cannot repeat it so many times. तुम्हारे पास time है, तो तुम बार-बार repeat करोगे. वो क्या करेगा? So he will divide the field into these kind of blocks. So what he will do? But we have to apply replication. Then we first divide the field into several parts. Grow one variety in half of these parts and the other variety in the remaining parts. We can then collect the data of each of the two varieties and draw conclusion by comparing the same. Okay. तुम बार-बार किया by dividing the plot. Okay. And then you replicate. You can do the same experiment instead 2 times or several times, 10 times. The results obtained will be more reliable in comparison to the conclusion we draw without applying the principle of replication. The entire experiment can be repeated several times for better results. Okay, so this is what is replication is. है ना? एक बार एक पूरा प्लॉट को डिवाइड 2 करके इंस्टेड तुमने बहुत तरह का डिवीजन किया एंड उधर आधा में ऑरेंज आधा में रेड लगाया. So actually 1, 2, 3, 4, 5 experiments we are doing, and 5 and 5, 10 experiments instead of 1 and 1, 2. Okay, what you can do here you can repeat it also every year and see the effect. So this is what principle of replication is. This is just simple replication. Randomization क्या है? That it provides protection when we conduct an experiment against the effect of external factors by randomization. Previously था by repetition, this is by randomization. It is just possible that the soil fertility may be different in the first half in comparison to the other half. मतलब इसमें soil fertility 2 half में different है. So we will have a different effect. Extraneous variable soil fertility is affecting instead of the rice or paddy variety. Okay. If this is so, our results will be not realistic. Okay. In such a situation, we may assign the variety of rice to be grown in different parts of the field on the basis of random sampling. तो हम लोग रैंडम करेंगे, कहीं पे भी बिठाएंगे. हाँ, फील्ड को बहुत पार्ट्स में डिवाइड किया, एक में ब्लू ऑरेंज ऐसा कुछ रैंडमली हम लोग ग्रो करेंगे. So that is we may apply randomization principle. इस principle के apply करने का मतलब randomization apply किया. This if we applied we wrote replication. So this is randomization. So this is the 2 basic process, and it protect ourselves against the effect of extraneous factor. Soil fertility will be here. We will ensure here what we will ensure. If it is adjacent, we will be able to ensure from rainfall. So this is better because both rainfall and soil fertility can be assured for the extraneous effect from the extraneous effect. Okay, and there is another principle which is a principle of local control. Here the variability, whatever the variation is occurring, is to vary deliberately over as wide a range as necessary, and this needs to be done in such a way that the variability it causes can be measured and hence eliminated from the experimental event. So treatments, what we are doing, fertilizer, we are giving the fertilizer treatment. Okay, extraneous factor is soil fertility, and experimental error we have to minimize. So we are basically doing a control experiment, control group and experimental group. We'll do somewhat in a different way, and we'll apply the principle of local control. So what we will do, we will assume, here some assumption is there that divide the field into several homogeneous parts known as blocks, and then each such block is divided into parts equal to the number of treatments. So we will assume that in each block the soil fertility is uniform. Then it becomes a control that we are not allowing the soil fertility to affect our experiment. So here the extraneous factor means the soil fertility is kept fixed in each block. We'll come into details in this more. Okay, and then we come. So these are the formal experimental designs. So these are the designs: CR design, completely randomized design, randomized block design, design. These are given in red, and factorial design in blue, because all the first 3 are called single factor. Botany logo pata hai. Single factor means only one factor can be found out. Means in these kind of design, will factorial design and multiple factors. Okay. So completely randomized design, these are the contributory. We are involving 2 principles: principle of replication and principle of randomization. The essential character of that design is that subjects are randomly assigned to experimental treatments. If we have 10 subjects and we wish to test 5 under treatment A and 5 under treatment B, means 10 subjects से 5 treatment A देंगे, 5 treatment B देंगे. Subjects means anything, huh? Plot or something. The randomization process gives every possible group of 5 subjects selected from a set of 10 an equal opportunity. Means no selection bias. Selection के तरफ हम लोग bias नहीं दे. This is randomized design. We in selection of the plots we are giving randomization principle. So we are removing bias in this case. There are two types of CR, completely randomized things. There are two types of things, two types of design. One is two group simple randomized design. So here two groups mean one there will be an experimental group and one will be a control group. So in a two group simple randomized design, first of all the population is defined. The whole population you have to design, and then whatever sample you are selecting is randomly done, and from the population and sample is selected randomly, no biasness. Okay, 5 पहले 5 बाद में ऐसा नहीं. 5 plots first, जो 5 plot आया उसमें पैडी डाला, one variety, and then 5 में different पैडी डाला, ऐसा नहीं. हाँ, randomly हम लोगों ने डाला. This is the selection. Complete randomized design is only selection of the field is done randomly, not anything else. Others are the other design. So here, remember, these are only for selection. Further requirement of this design is that items after being selected randomly from a population be randomly assigned to experimental control groups. Then assignments of experiment, किसमें fertilizer डालेंगे और किसमें नहीं डालेंगे, वो भी random निकलेंगे. We'll do it randomly, not a particular pattern follow नहीं करेंगे. हाँ, random जैसे हम लोगों ने किया. So a two group simple randomized design is a classical example of one factor experiment in agriculture, sorry, botany में. हाँ, the factor इसमें क्या है? Factor means independent variable. One factor design means only you can have control of one independent variable, that is fertilizer. You cannot see the effect of two factors at a time. So all these designs are concerned with the relationship with only one independent variable. The red ones, completely randomized design, randomized block design, and lattice square design. Here you can only have control of only one factor or one independent variable. Factorial design are multi-variable. Means you can introduce multiple independent variables in that for changing or for observing the effect on dependent variable. So these hypotheses will be only two factors or two variables, one independent variable and one dependent variable. But in factorial design, you can propose a research hypothesis based on multiple variables, multiple independent variable effect on one dependent variable. Okay, so this is what. And in the first category, completely randomized design or CR design, we are introducing randomization only in the selection of the field. Okay, selection of the subjects. So here it's a classic example of one factor experiment. The factor, that is a fertilizer type, can have two levels. But you can check, okay, two types of fertilizers, and subjects are randomly, subject with plots are randomly assigned to treatments to test the effect on crop performance. Only one independent variable is studied. Treatment, the factor has two or more levels. You can give 2 fertilizers or 10 fertilizers. The goal is to study how that one factor, fertilizer, affect the outcome. That is the dependent variable. So in agricultural terms, these are what factors and level of factors and response means. Factor is a controllable input that you want to study, type of fertilizer. Yeah. Factor, why this we are calling it factor? We called it independent variable earlier because in agriculture terms, these are used. Levels of the factor, how many treatments? Fertilizer A and fertilizer B means 2 fertilizer testing, there are 2 levels of treatment. Response variable, outcome you measure, crop yield, kg per plot. No other factors are varied. Huh? Then they are kept constant across all plots, irrigation, seed variety, planting date. Huh? Then it is called a one factor experiment. If you vary 2 factors, we cannot do it by these kind of designs. So CR design we were doing, CR design contains of CR design. See, completely randomized design. Those are of 2 types, 2 group, experimental group and control group, and random replication design where there are multiple groups. You, instead of 2 groups, we did here, see here, we did 2 groups. This is an example of 2 group, okay, 1 and 2, experimental control. But here it's a multiple, huh? So once, and if that multiple is done randomly, huh, then this is a CR random design. This is number 2, random replications. You are doing random and also replication. So here, what is the benefit is that to estimate the natural variability in the experiment, to increase precision, and to ensure reliability and repeatability of the results. A random replication design is essentially a completely randomized design. This is also CR design with multiple replication of each treatment. Treatments are assigned randomly to experimental units, and each treatment is repeated to ensure accurate, reliable, and statistically sound comparisons. Okay. So whatever the limitation, where we understood that there was limitation in the two group. If you have two group randomized design, is usually limited within this replication. You do multiple units. So there were two groups earlier, but here now there are multiple groups. There are 4 experimental groups and 4 control groups, like that. And you applied the design in that way. So this is an example. And what comes next is the randomized blocks design. So just it is an improvement over the CR design. The previous design was the CR design. In randomized block design, subjects are first divided into groups known as blocks, such that within each group the subjects are relatively homogeneous in respect to some selected variable. Okay, so these are randomized block designs. The variable selected for grouping the subject is one that is believed to be related, to be measured, and to obtain in respect to dependent variable. The number of subjects in a given plot will be equal to the number of treatments. In general, blocks are levels at which we hold the extraneous factor peak. The main factor of RB design is that in this each treatment appears the same number of times in each block. So what is this? And it will be analyzed by ANOVA technique, two-way analysis of variable. ANOVA technique we will learn in the statistics classes, in the next classes. So here we will understand what it is. So you have 3 fertilizers, A, B, and C. There are 3 fertilizers with you: A fertilizer, B fertilizer, and C fertilizer. And replications, here you are blocking it. You are creating block. In what? Why you are creating block? In agriculture, fields are really uniform. Variability, where the variability exists in soil, topography, sunlight, etc. So this randomized block design. So what you do, you are in a randomized block design. What you are doing, you are creating blocks. You have a plot. You are creating blocks within that plot. Okay, multiple blocks. Because what we say that in each blocks, the sunlight, the soil fertility are different. But we are assuming in this design that the whole plot we are divided into blocks. Each block is having the same fertility, means the variability which had an effect on the extraneous factor is homogeneous within that block. They sign. So this is how a randomized blocking is done. So that blocking is done randomly, and how you will do find out the effects in the fertilized ABC, 3 treatments you are doing, and you have to compare how these 3 fertilizers have effect on your paddy. And you have one plot. So what you have to do? So you have to replicate. You have to do for these 4 blocks due to expected variation across the field. This one you can do multiple, more than 4 blocks as well. And total plots, you have to do 3 treatments, 3 type of treatments into 4 blocks is equal to 12 plots is required. So in plot 1, so the first plot you do 4 blocks. If you do in plot 1, there is no plot 2 and 3. So in plot 1 you do 4 blocks, A, C, B, A. So in first block you put A, in second block you put C, third block you put B, and fourth block you again put A. Okay. So here in plot 2 you do it in a different random way, B, A, C, C, and this C, B, A, C. So you see in the first block, in this first block you have only A, B, C. In the second block you have only A, B, C. In the third block only you have A, B, C. And in the fourth block you are also having A, B, C. So here the selection in one row you are ensuring that only, since you have 3 treatments, so the number of rows will, so 1, 2, and 3. So row wise there will be only 3, means the column is fixed 3. Okay, and the number of rows you can increase. I have shown 4, you can do 10 also. Okay, so you have more plots, you can do 10 more replication, better the output will be. If you do not have so many, the minimum will be 3 by 3, but you have to divide your whole, at least your whole plot into 3 plots. Okay, 1, 2, and 3 3 में डिवाइड करना ही है, बिकॉज ABC 3 फर्टिलाइजर्स हमें इवेल्युएट करना है। 3 फर्टिलाइजर्स हमें इवेल्युएट करना है, मतलब हमें 3 कॉलम्स चाहिए ही चाहिए। 3 कॉलम्स में हमें रखना है और एक एक रो विल बी सेम। ABC एक ही बार होगा, 2 बार नहीं आ सकता। ओके, so this is the whole principle. But if you have in plot 1 you can make 10 blocks, you do it, and in 10 blocks you put AC, BA, BC और बार बार कुछ भी सिलेक्शन रैंडमली तुम वैरायटी ऑफ पैडी लगाते जाओ। ठीक है, ये समझे ना? You can do number of blocks as 10 and but each block में रो वाइज 3 ही रहेगा। हाँ, एंड रैंडमली लगाएंगे, देयर इज नो सीक्वेंस विल फॉलो ABC 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 या AC ABC ABC भी कोई सीक्वेंस नहीं, रैंडमली विल डू इट। देन दिस काइंड ऑफ ब्लॉकिंग, हाँ, द होल प्लॉट इनटू ब्लॉक is known as random block design. So this is what is known as RBD. So this is one type of agricultural design which is introduced to study a one factor effect. Means you can study only one factor, fertilizers. Number of fertilizers you can increase. So basically it is, if the treatment number of T is 3, then it will be 3 into n number of blocks. Okay, but 3 into n, 3 is fixed because one is T, the other you can vary. Okay, this is what is a randomized block. Okay, the more the number of n, the number of repetitions you are doing. Here what you are doing, randomly selecting. As I told you, selection is random, so randomly you are selecting and putting the fertilizers, and then if you put the number of n, what you are doing, you are repeating, so you are replicating. So randomization also, replication also, both we are introducing in our random block design. But why it is called random block? Because the blocking is done randomly. In those each blocks you are randomly putting ABC. This is how it will look like. Okay, this is about the random blocks design. And then this is one example, will come later. Then there is a lattice square design. So lattice square design, here the lattice square design will go directly into the example because these are all text. So here in the lattice square design, what you do is that here you also treatments. So if you want to have effect of 5 fertilizers, 5 type A, B, C, D, E, then in lattice square design, it's always a square. Okay, so basically here there were the blocks selected where T into n number of rows we could have. Here the number of rows are fixed, T into T. Okay, 1, 2, 3, 4. So you will have 3 treatments. So you have 5 treatments, 5 fertilizers. Then layout will be a T into T square. So that is it's a square design. Okay. So this is the difference between the two, randomized block design and lattice square design. The basic difference is in randomized block designs you separate into blocks where the blocks in each row you are keeping ABC only once, but according to the column it can vary. But here you see this ABCDE comes only once along the row also, along the columns also. Okay, so this is how the blocking has to be done. Okay, since it is a square, if you see in none of the row it is repeated 2 times, and in none of the columns it is repeated 2 times. So basic difference between the two is this only. See, in a randomized block design, along one row we are not repeating, but along a column it can repeat. Okay, replication can be there. Here this is the difference. Here it is once only along the column or along the row. So the lattice square design is one where each fertilizer in our example appears 5 times, but is used only once in each row and each column of the design. No treatment occurs more than once in any one row or any one column. 2 blocking factors may be represented through rows and columns. Okay, so this is what their ANOVA technique again is used. And then we come finally into the factorial design. Factorial designs are used in experiments where the effects are varying more than one factor. Suppose now we were discussing only the effect of fertilizers. We have to different effect of more than one. They are specifically important in several economic and social phenomena where usually a large number of factors affect a particular problem. Generally, as I told you, it's in every variation, in most of the variation, the dependent variable does not depend only on one independent variable, but multiple variables. So you have to, so this is a strategy where you can publish multiple papers, right? You vary one by one. So your composition have an effect, your structure has an effect, your morphology has an effect. Huh? So your thesis should be a factorial design, means a very well effect of multiple independent variables on your dependent variable, on your performance of your material of interest. Okay. Factorial design can be of two types, simple and factorial design. We'll discuss only simple. We'll not go into complex. SAES of what complex. And complex factorial designs we'll avoid. Okay, but there are two types. Simple factorial designs means in the case of simple factorial design, we consider the effects of only two factors on the dependent variable. You have only two factors at a time you can do. Okay. So what is the general strategy? See, suppose I always tell in catalysis, we do catalysis research. So there is a reactor in high temperature catalysis, say suppose. So there is a reactor. This is suppose a reactor, and you have the inlet reactants coming through this, and this is the your catalyst bed, and you have the outlet going through this. Okay. So here, what so many factors can take place. Okay. Here you can vary the flow rate, not the catalyst. You are designing the catalyst, but this reactor design itself, you can vary so many things. You can for the same catalyst, you can vary the flow rate, the composition of the two mixtures, the composition of the diluent which you are giving, the flow rate, the pressure which you are applying, the pressure drop which is taking place, the temperature of this. So many things you can vary. But if everything varies in one single experiment, you will not be able to come to a conclusion. So if you want to vary the effect of composition of the reactant gas, then you have to keep the flow rate same. You have to keep the temperature same. This is what is done here. Means other extraneous variables means if you are analyzing the effect of flow rate on the catalytic activity, you have to keep the temperature, the pressure, and other factors same. Okay. If you want to plot the temperature of this bed, the temperature of the catalyst bed versus the output, how much we have got as product yield, then you have to keep the composition, the flow rate same. So each factor you vary, all other factors has to be same. The independent variable which you are varying is the independent variable. All other factors which affect the dependent variable are the extraneous factors. So we say we do a control experiment where we have kept all other factors constant and only the independent variable of my interest. That is, if I want to measure the effect of temperature on the catalyst performance, I'm keeping the flow rate, the composition, and everything same. This is what we do. That is why I'm familiar. Other things are all agriculture. So there you are using only two. Simple factorial design is also termed as a two-factorial design, wherein the complex factorial design is known as multifactorial design. Simple factorial design may either be a 2 into T simple factorial design, or it may be say 3 by 4, 5 by 3, or any type of simple factorial design. So again, we do a simple factorial design. We just see how do we see. So the question is how do type and irrigation level. So two factors, independent variable, fertilizer type and irrigation level, affect the yield of your wheat. Instead of rice, we are doing wheat. So fertilizer type and levels A1 and A2, and B is irrigation. One is A1, organic, means organic or no fertilizers or organic, and A2 is chemical, you are giving urea. And B is irrigation level. B1 is low and B2 is high. So how many combinations we can have in selection is fertilizer can be A1, irrigation can be B1, fertilizer can be A1, irrigation can be B2. Again, fertilizer when it is A2, irrigation can be B1, B2. So A1, B1, A1, B2, A2, B1, A2, B2. These kind of 4 treatment combinations we can have. Now, these treatment combination you have to do a replication as well as randomization. So A1, B1, A1, B2, A2, B1, A2, B2. These are the treatment combination, and randomly you have to assign plots and replicate the same. Okay, so A1 B1 combination is replicated 3 times. So okay, so your column is fixed 3 into how many times you are there are 4 you are doing. Okay, and if you want have more plots, you are rich farmer, you can go on doing as many as possible. But you have to see whatever design you are making can be generalized, has an effect. The fertilizer and irrigation effects in these 12 plots, there are 12 plots here, 4, 4, 4. If you have 36 plots, you can go here 1, 2, 3, 4, 5, 6, and again 1, 2, 3, 4, 5, 6. 6 by 6 you can design. So if you have 36 plots, it will be more reliable. Just is it. But you have, as I told you, now comes the sampling effect. Means how we will choose the sampling, how many you will choose. That design you have to make so that you can come to a general conclusion that organic is giving lesser yield, but irrigation with B2 is giving better. Okay, like that. So what will be the sample? You can take 36 or you can take this much of 12. So this is nothing but sampling, right? In this design, you are defining the sampling. So irrigation and fertilizer, you are varying and seeing the effect, how it is affecting the crop yield. You can do it in multiple ways. Suppose we are doing factorial, we have to decide whether we'll do 36 or 12. So that is the effect of sampling. It should not be too big that it takes very huge time or resources are not with me. I do not have 36 plots. I have to manage with 12 plots. Okay. I do not have irrigation water for 36 plots. So I have to manage with 12 plots. But again, if I do it with 6, it will not give you a true picture. You cannot generalize it for everywhere, universal. You cannot make it universal. So you have to go for 12 at least. So this is what is sampling is important. How many you will take, that decision you have to make. So these are the advantages. So here we did all types of research design up till here, and you have to, why I start here right now, sampling design. From here the question, and it is quite clear that we have to throw a theory, or you will propose a hypothesis testing which can be generalized, okay, which can be applied universally. So for that we have to define the sample, depend upon what my resources, my skill, my time, my money, whatever is available. So the steps, what are the steps in sampling? The type of universe, the sampling unit, source list, the size of the sample, parameters of interest, budgetary constant, and sampling procedure. So these are the steps you will involve during design of the sampling. And what will be a characteristic of good sample design? That sample design must result in truly representative sample. Okay. So in the earlier case, if the 12 plots can give you a proper or a true picture of the effect of irrigation and effect of fertilizer on the crop yield, then my 12 plots is a good sample. Is a truly representative sample. If it is giving you a result which cannot be generalized, it's less, then it is not true. You have to go to higher. So sample design must be such that which results in small sampling error. So if we selected only 3, definitely we'll end up in a error, because हम लोग उस तीनों से irrigation और fertilizer effect control नहीं कर पाएंगे. Whatever outcome we will get in such a design, we will end up with error. So minimum हमें 3 by 3, 3 by 3, 9 plots हमें देखना ही चाहिए. Sample design must be viable in the context of fund available for the research study. So if a farmer has only a small plot, only 12 plot, he cannot even dream of doing a 36 plot experiment. Okay, sample design must be such so that the systematic bias can be controlled in a better way. So sampling has to be done randomly, so the systematic biases are removed. Random samples हमें करना पड़ेगा. Samples should be such the results of a sample study can be applied in general. So the results from the 12 can be applied throughout at least his province or his district. So for the universe means of his place. Okay, universe to be defined करना है with a reasonable level of confidence. So with the level of confidence, I can say, okay, in Maharashtra, in Panvel, in Raigad district, I have done an experiment with these 12 plots of irrigation and fertilizers, 2 fertilizers and irrigation, and this is the best outcome, A1, B1. Okay, A1 B1 will give you the best output. So everybody will follow A1 B1 in this universe, means in this district. It will not be helpful in somewhere in West Bengal, right? कोई बोल रहा था आज, he is learning Bengali words. I don't know कौन बोल रहा है, क्या हुआ? So it, because there the soil variety is different, soil fertility and the soil, all these conditions are different. So this is what the sampling is all about. Okay. So we learned all these stages. So the factorial designs, there are two advantages they say, and then we come to the final part of research design. We just skipped it for continuity in this case. That is what is observation, what is fact, what is law, and what is a theory. Okay. So these I took from internet, not from the book. That is why I am mentioning it here. कहाँ से लिया है? So direct measurement or data point gathered from the reality through sensory experience or instrument can be termed as observation. So when I dropped a ball, it fell to the ground. This is the observation you make. I have made that when I drop this pen, it will fall to the ground. Okay. This is what Newton saw, ना? उस टाइम रिसर्च मटेरियल नहीं था, लेकिन फिर भी सब कुछ he has invented. So you can understand. So this is an observation. So you will repeatedly make observation during your research methods and career research. So daily you are taking an observation. And what is the difference between an observation and a fact? A fact is a basis statement that is established by experimental repeated observation. So every time you will, what you will do, you have observed this. So what you will do, you will drop this several times. आज भी डाला, कल भी डाला, कुछ अलग कभी ऊपर जाएगा? So नहीं जाएगा. So then it becomes a fact. So you will have a level of confidence. You can tell with a level of confidence that I am getting this, okay, in some experiment, a peak always at 0.5 volt. Sir, मुझे 0.5 volt में ही मिल रहा है. But somebody else तो 0.7 में बोला है. तुम repeat करोगे, लेकिन तुम्हें 0.5 में ही मिल रहा है, हाँ? Then और भी repeat किया. Then that observation becomes a fact. You can tell with confidence, नहीं sir, मुझे 0.5 में मिल रहा है, मैं सब repeat किया. So then we will sit down and analyze कि क्या हो रहा है, हाँ? So and then what is a hypothesis? A ball drops because there is a force pulling it down. So there is you introduce a force and a hypothesis which you will do research. Newton ने किया था क्या ऐसा hypothesis? And because you relate that dropping with the force, एक force के साथ correlate कर दिया. And then what is a theory? A scientific theory is a collection of laws, principle, concepts. It's collection, okay, and facts united together into a self-consistent framework that has been verified experimentally and is able to accurately describe every aspect of a system or field of study. So mass and energy cause space-time to curve, and the force of gravity arises from the curvature of space-time. So in a theory, what is there? You will have the reason in it. Whatever you are observing and it has repeated, it becomes a fact. And if you can explain it with a reason, you tell it is a theory. So, and what is a law? A law is a mathematical expression which does not cause the reason. So, reason nahi hai, any particle, scientific law. I'm not talking about legal laws. तुम गलत काम करोगे, पुलिस लेके गया, बोलेगा थ्योरी दिखाओ, ऐसा नहीं. No, you have to वो अलग लॉ है. सो साइंटिफिक लॉज में जैसे बॉयल्स लॉ, चार्ल्स लॉ है ना, दीज आर लॉज. वो मैथमेटिकल है, पीवी इज इक्वल टू एनआरटी. तुम डाउट करोगे क्या? लेकिन उसमें तुम्हें पता है क्या वो पीवी इज इक्वल टू एनआरटी से क्यों प्रेशर इज इनवर्सली प्रोपोर्शनल टू वॉल्यूम? उसमें कहीं नहीं दिया हुआ है इन दैट लॉ. तो लॉ इज अ मैथमेटिकल एक्सप्रेशन which is of a natural law that is consistently occurs but does not explain the reason behind. Okay, so this is what is a law. So these four differences you should know. Daily you will encounter an observation during your research, okay, and then you repeat it and you see that observation is repeating, observation is become generalized, so it becomes a fact. Then you propose a hypothesis with that. You then at the end of your research career you propose a theory that the reason of you tell ये hypothesis में जो बोला था ये ऐसा ट्रू हो रहा है, लेकिन उसका रीजन क्या है, that also. And if you are good enough, I don't know if it can be done mathematically, then you can propose a law also. हाँ कि quantitatively अगर तुम explain कर पाओ, everything is not quantitative, so law may or may not be told. So this is how the difference between fact, observation, hypothesis, scientific theory and a law. जैसे kinetic theory of gases, okay, kinetic theory of gases is a theory, huh? And within that PV is equal to nRT or Boyle's law, Charles law. So theory is तुमने पढ़ा है, everybody has read through kinetic theory of gases, and within that you have certain law. So in general, how I took from internet one, it was very nicely explained that you propose a hypothesis, okay, several hypotheses, huh? One hypothesis between two, an independent variable and a dependent variable. Another hypothesis on another independent, similarly related independent variable and dependent variable. And what you test it. Hypothesis means testable, okay? Testable assumption. So you have to test it. So you test it. How we will test it? With the help of data collection. Huh? With the help of data, you come to a conclusion. Since the data is repeated and you have confidence, it becomes facts. Huh? So with this you can conclude your PhD thesis, right? With this itself. But instead you just think, if you can propose from this conclusion fact, you sit down and you can develop some law or principle. Okay, then you actually are proposing a theory. So target something big, huh? So you will be able to propose some theory after your thesis. So this is what and for PhD you will get an one opportunity, right? किसी को 2 बार करना है तो करो. मैं मना नहीं कर रहा हूँ. हाँ, there are people who does double doctorate. हाँ. So give your best. हाँ, जहाँ पे भी join कर रहे हो, it's your decision. Give your best so that see you will have one opportunity. उसके बाद भी research you can continue. हाँ, research तो continue कर सकते हैं. हाँ, but PhD करने का opportunity तो एक बार मिलेगा. So we will give our best so that you end up with very good theory. Huh? Okay, this is what we had, and we will go for collection of data tomorrow. Huh? कल करेंगे. Huh? With data collection, and then execution में कुछ नहीं है. Huh? हाँ, तुम्हें करना है. And then we something about analysis of data we will tell. Okay, next to next class. So these are the assignment. If you do, it will be benefit you. What is it? 3:30 हो गया? 3:40 हो गया.